All right, so section 6.2 is all about right triangle trigonometry. And so when we talk about our right triangles and the trigonometry in right triangles, we always refer to one particular acute angle. In this case, we'll use the bottom left angle, theta, as the angle we're looking at. And so in relation to theta, you have the side that's opposite of theta, you have the side that's adjacent to theta, and then your hypotenuse, which is of course always opposite the right side, the right angle in the triangle. And so we simply call the side opposite theta opposite. The side adjacent to would just be adjacent. And then using these lengths of the three sides of the triangle, we can find the 6 trigonometric functions by looking at ratios. And so our 6 functions are sine, cosine, tangent, cosecant, secant, and cotangent. And I've given you here their abbreviations for each so that you can become familiar with them. So when we talk about sine, the ratio for sine is always opposite over hypotenuse. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. And so you may remember when you took geometry, learning about SOHCAHTOA, to help you remember these trig ratios. And so if you can remember these 3 basics, then the other 3 follow just from that. So remember, sine is opposite over hypotenuse. That's what the O and the H are for. Cosine adjacent over hypotenuse, and then tangent opposite over adjacent. Now the other 3 are the reciprocal of sine, cosine, and tangent. So cosecant is the reciprocal of sine. It's hypotenuse over opposite. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. And then tangent and cotangent are reciprocals, so cotangent would be adjacent over opposite. So we're going to look at 2 examples here, and then you'll have time to work independently. Remember also you have a take-home quiz that needs to be completed prior to you coming, by the end of the day on the 30th, which would be Monday. Okay? Now, you'll notice that for each of these right triangles in example 1, we only have 2 sides. Now remember that the Pythagorean theorem gives us the third side of any right triangle. And so we can use a squared plus b squared equals c squared in order to find the missing side. So for a, that would be 3 squared plus 4 squared equals c squared. Remembering c is always that hypotenuse. So 9 plus 16 equals c squared. 25 is c squared, so c is 5. So this would be a 5 on the hypotenuse. On B, I've been given my hypotenuse. What I'm missing is one of the other sides. So we're going to put a squared plus 2 squared equals 4 squared. So this is a squared plus 4 equals 16. A squared equals 12. And when I square root this, 12 is not a perfect square. So remember, we're going to separate 3 and 4, which is 2 and 2. So this would be 2 square root of 3. Okay? Now we want to find the 6 trig functions. So we're talking about sine of theta, cosine of theta, tangent of theta, cosecant, secant, and cotangent. All right, so sine is opposite over hypotenuse, 4 over 5. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Cosecant is the reciprocal of sine. Secant, the reciprocal of cosine. And cotangent, the reciprocal of tangent. And those are our 6 trig functions there. For B, sine would be opposite over hypotenuse, so 2 over 4, which is 1/2. Cosine would be adjacent, 2 square root of 3 over 4. which is square root of 3 over 2. Tangent would be opposite over adjacent. Now the 2's cancel, and we're going to need to multiply by square root of 3 to get rid of the square root in the denominator. So this would be square root of 3 over 3. Now for our other 3, we're going to use the reciprocals of what we've calculated already. So cosecant should be 2 over 1, which is just 2. Secant is 2 over the square root of 3. We need to rationalize that. So we get 2 square root of 3 over 3. And cotangent is going to be the square root of 3 over 2. Okay? And then for example 2, we're going to kind of do the same exact thing. This time we're using a 45-degree angle, so either one of these is appropriate. So if we do the sine of 45 degrees, we get 1 over the square root of 2. When I rationalize that, I get square root of 2 over 2. Cosine of 45 degrees is going to be the same thing, square root of 2 over 2. The tangent of 45 degrees would be 1 over 1, which is 1. And finally, secant of 45 degrees should be reciprocal of cosine, which is just square root of 2 over 1 or square root of 2. All right, and this is all you got for today. You'll work on your assignment, and if you finish early, work on your take-home quiz. Have a good one.